In this video, we're going to look at inverse functions. Inverse functions are where you switch the domain and the range. And that's pretty much all it is. For example, let's say I had f of x was equal to the set of ordered pairs where I had 1, 2, 3, 4, and 5, 6. Each one of these ordered pairs represents my domain and its corresponding output, the range. The inverse, which I use f negative 1 of x, this is the notation for an inverse function. I'm just going to switch the numbers around. The effect of what happens when you look at a graph of any inverse function is you have a line y equals x. And this becomes a line of reflection. For example, if I have the coordinate point 1, 2, that will be up here. That's going to get reflected to the coordinate point 2, 1. The coordinate point 4, 3 may be somewhere here. That gets reflected to 3, 4, which is going to be up here. Now, when you reflect something over a line, this segment here is congruent to this segment here, and they'll reflect at right angles. So you can imagine 5, 6 would be somewhere over here, and that reflects to 6, 5, or no, sorry, this is 6, 5 over here, and that reflects to 5, 6. So the same thing happens. Now, when you reflect curves, you just reflect the curve over that line. So if I had something that looked like this, I would reflect it across and it would look something like this. Well, actually something a little bit better like that. There we go. Kind of freehanding it here. But you can see that the distance between here and here is going to be the same. The distance here and here is going to be the same. The distance between here and here is going to be the same. Now, a calculator is obviously going to be able to do this a lot better than I can by freehanding it. But one thing that you can do is that you have your original graph. You can actually fold your piece of paper on that line and trace it through, and then you can find your line of reflection by doing it that way. Let's talk about what it means to be one-to-one, or we can do one-to-one here. We know that functions, for every input, there's one output. For a function that is one-to-one, it works both ways. For every input, there's one output, and then for every one output, there is one input. So that's what it means to be one-to-one, is that there's a one-to-one correspondence for every element in the range corresponding with every element in the domain. What it looks like when you actually graph it is that it passes both the vertical line test for a normal function, but then it also passes the horizontal line test in the same vein of the vertical function. So in other words, we look at it and we decide, does it cross it twice or more times? And if not, then it's going to be a one-to-one function. For example, let's say I had a function that looks like this. It passes the vertical line test, no problem. It also passes the horizontal line test. So in this case here, this function would be one-to-one. If I looked at a graph of a parabola, this is a function because it passes my vertical line test, but it does not pass my horizontal line test. So this is not one-to-one. Same thing if I had a cubic that looked like this. We pass the vertical line test, so it's a function. Does not pass the horizontal line test because it crosses at two or more places. So this is not one-to-one. Now, all one-to-one gives us is that the inverse function is also a function. So when we have this, that means that f of x, f minus 1 of x, which is the inverse, is a function. So let's talk about finding inverse functions. And I'll do this in my next video.